In this video, we'll be showing our demo of a secure access to the test infrastructure as a collaboration between Tima and LIRM inside both working packages 1 and 4. The use case is the user trying to execute some PDL1 code on an embedded register. This code executed a series of writes and reads a hard-coded value. The system is simple enough that it's easy to follow through simulation traces, but still it's complex enough to require a full bidirectional communication with the system under test. Security, as a first step, is provided through an SSH challenge response controller, where a secure SIB is open only after authentication so that access is restricted only to authorized users. This system is described using a simplified equal-tree format that is a simplified version of ICL that we use for this type of experimentations. Most notably, we can see that here we have our register that is behind the secure SIB, and here we have the controller with the key for the authentication. To make the execution, we use our MAST tool in a trusted tool setup, where we give it this SIT with the credentials, which will be used by MAST to call up the implementation of a SSH protocol. Similarly, our PDL1 code has been compiled to obtain a dynamic library. The execution will also generate a log file that can be used to monitor the execution. To obtain a co-simulation setup, we'll be instantiate before our system a slave tab that is able to communicate outside of Modelsim thanks to some exchange files together with MAST. So here we can see our system under test that is instantiated inside together with this tab communication with the external, and inside we find the different parts, most notably the controller and the target register. In the command line, we can see that we have our precompiled libconsole increment dynamic library, and also here we have our SSH library. Execution is simply obtained by calling up MAST and giving it the right SIT. Then we launch the execution, and we can see in the console everything worked correctly. By looking inside the log file, we can see that the authentication was successful thanks to this challenge response method. Inside the traces, we can look we can see that our come from the beginning. We can see first of all here, this is the state of a secure SIB. We can see that's been unlocked thanks to the authentication, and then our register will have 1, 2 of the values that we wanted to write arrived in the system. So this proves the correct execution. But what happens if there is a problem with authentication? We will just change here and put a wrong key and relaunch the simulation. We can see that MAST raised an error because there was an authentication failure. And inside the log, we can see that we received an error message and no communication has been done with the system. We can also, if we put back the value, once more, our execution works. And we can see inside the here the data has been exchanged through to the system with this thanks to the execution. We can also try and completely disconnect the simulation backend. And we see that we receive an authentication timeout because the system tried in this time 5 times to get the authentication. Each time it received the wrong value because there is nothing that being executed behind. So the system is still working even in the case of a hang up of the system under test. As an additional security layer, we implemented also a stream cipher as a trivium that is put at the top level before the tap. The idea is that all data that is exchanged through the JTAG interface will be encrypted through a key and an initialization value to assure complete protection. Once more, in MAST, this is done by just instantiating this trivium module and giving the implementation to the system. This is a little bit more complex because we only had a Python implementation, but still we have this introduction, this adaptation. If we look at the system, we have the same tab, but we have the cipher in the middle now. And then behind we find the same example with authentication controller. So we can launch execution like usual, but by calling the trivium SSK, where we have this translation that is on the beginning. So we can see the execution is performed exactly in the same way. We can find in our implementation that the SIB was opened, the secure SIB, and then find our results. But more importantly, if now we look at the data that's been exchanged, we can see that the data was completely encrypted. It's not possible anymore to snoop the data that was exchanged with the system. And this is the end of this presentation.